Very good morning friends, and in this video we are going to understand the graphical nature of the trigonometric functions like sine, cosine, tangent, cotangent, secant and cosecants, also called as cosec and sec respectively. So the graphical nature means how these things and what are the domain and the range of these trigonometric functions. So first let me plot the sine graph. So this is my y-axis and this is the x-axis. So you know that sine function sine x is changing its values from, like if I just plot some set of values. So we have seen that when we wrote the angle values, then sine functions of 0 degrees, 30, 40, 45, it should be 45, yeah, 45, 60 degrees and 90 degrees. So sine 0 is 0, sine 30 is half, this is 1 over root 2, this is root 3 by 2 and this is 1. So if you plot these values, suppose if I just express this values in the decimal fractions, so 1 by 2 is 0.5, this is root 2 is, if you rationalize it, then you will get the multiply up and down by root 2, so you get root 2 by 2, that is 1.4 something, divided by 2, that is 0.7 kind of, and this is 1.732 and this is 2.8 and this is 1. So this just gives you one brief understanding that when the angle changes from 0 to 90 degrees, then sine value changes from 0 to 1. So the graph goes like this. And then when the angle changes from 90 to 180, then it comes down. Like this. And here also in this section also it goes like this. Okay. So this value is 0. This peak value is pi by 2. So this is pi by 2. This is pi. This is 3 pi by 2. This is 2 pi. Now this is our x-axis and this is our y-axis. Now, so see here the value when it goes from 0 to 90 degrees, then its value started from 0 and reaches the maximum peak value. So this peak value here is 1. So when the angle changes from 0 to 90 degrees or 0 to pi by 2 in terms of radian, then the value of sine changes from 0 to 1. And then the angle changes from pi by 2 to pi, the value starts decreasing and you get the value as 0. Now how can you say that? So suppose when I go beyond 90, suppose I have sine 120 degrees, then how do we do that? We do sine 90 plus 30 degrees. So sine 90 plus 30 degrees, in this case sine will become cosine, so this will become cos 30 and cos 30, and in the second quadrant the sine of SI is again sine of sine, because you remember when we discussed ASTC. So in second quadrant sine is also positive. So this value from to here it is positive, but it is in decreasing order because sine 30. This is cos 30 and this is root 3 by 2. So this is 0.8 something. If you remember that in the cosine table we have, this is sine, then the cos for this table goes like, we used to write like this, root 3 by 2, 1 by root 2, this is 1 by 2 and 0. So now here I am getting cosine, cos 30, so 90 plus, when I go into this order then you start getting the values like this. So it means 1, 0.8, 0.7, 1 by 2 and 0. It means from here to here, when the angle changes from pi by 2 to pi, then this value starts decreasing here and you get the number from 1 to 0. Then here you go into the third quadrant. Here this doesn't look uniform, so let me make it like this. Yes, 2 pi comes here and this value is minus 1. So now from pi to 3 pi by 2 in the second quadrant, the value goes from 0 to negative 1. So again 0 to minus 1, and then from 3 pi by 2 to 2 pi, it again from minus 1 to 1. So the one complete cycle, and this is flipping between minus 1 and plus 1, angle changes from 0 to this, and this is the periodicity because it repeats every time after the interval of 2 pi. So the periodicity is 2 pi, and the domain of this, domain is what possible the values on x-axis does it take. So you see it takes everything. So we have the domain as whole real line. So our domain is whole real line. Domain is what possible values does it take on the x-axis. So it takes everything because there is no gap, graph is continuous. So it takes every value on the graph, on the x-axis, and on y-axis that is called range. So here you see y-axis, it is limited between this and this. Always the graph is flipping between this. So this is my range, and that is minus 1 to 1. So what is right? Range is minus 1 to 1. At the same time, suppose if I say that I want to understand the cosec also reciprocal of this, then you will have the graph of cosec. Cosec is reciprocal of this. So the cosec x is 1 over this. So now you see when this is 0, so 1 over 0 is undefined. So you get your graph parallel to y-axis. And then you are reducing, and here becomes 1. And then again, when it is, because reciprocal, 1 over sine. So when I write 1 over 1 over 2, 1 over 1 over 2, this becomes 2. So it will start increasing. So here when it is increasing, sine is increasing between 0 to pi by 2, and its reciprocal will be decreasing from 0. Is 1 by 0 is infinity, so infinite, like the parallel to y-axis, and then from where it's decreasing until it reaches to 1. So 1 by 1 is 1. Then again from here the graph is decreasing from 1 back to 0. So this again starts increasing from here, and this becomes parallel. So at this point, if you draw a line, so your graph will be becoming parallel. So it will have the cusps at those vertex points, and this is the graph of the cosec function, like this. And what will be its domain and range of the cosec function? That is the range. You see that the graph of this one, the cosec is going from 1 to infinity, because it's not coming down, it is going from here, you see, 1 to infinity, and then down here minus 1 to minus infinity. So your range for the cosec function, range for the cosec function will be minus, this is 1 to infinity, so 1 to infinity this is open bracket, and the union of that with this value, which is from -1 to minus infinity. So this is -1 to infinity. This is the range, and the domain you see, wherever this graph is becoming parallel, like wherever the sign was 0, that which should not be the part of this. So pi's, 2 pi's, minus pi's, so all these are omitted. So the range means the domain of the cosec function, domain will be whole real line minus n pi, where n is the integer. So r minus n pi means it cannot be 0 pi, because here it is 0. So 1 upon 0 is undefined. It cannot be pi because 1 upon 0 is undefined. Means wherever the sine function cuts the x-axis, that cannot be the domain of cosec function. This, and after this again it will come. So this is wherever sine is 0. So where is sine 0? Sine is 0 at n pi. 0 pi, 1 pi, 2 pi, 3 pi, minus pi, minus 2 pi, minus 3 pi. We call it n pi. So the domain means cosec cannot have those values. So whole real line minus n pi. And the range is again what the values. So the cosec doesn't take these two values. It takes everything. So you can also say that the whole real line minus anything coming between 1 to 1. But this part is included, so I can make it better. Open interval like that. And that is the graph of sine and cosec. Now I have to clear the screen, and then in the next part, not in the next video, just after a while, I will explain you the graph of. Okay, now we'll be discussing the graph of cos x and its reciprocal sec x. So the graph of cos x goes like this. Is like that. Something like that. It's cannot be drawn perfectly like this. So in this video I will add some graph generated by the computer also, so you can later understand how the whole thing looks in the computer graphics. That will be better than this, but actually it will be very much same like that. So you just saw that the cos x means, if I just explain you the value of cos x, then you see that for the angle 0, 30, 45, 60, 90, cos 0 is 1, cos 30 is half, that is 0.5, cos 45 is 0.7, that is 1 over root 2 kind of. This is 0.8 and that is 0. So when the angle changes from 0 to 90, then the cosine function, the value decreases from 1 to 0. It means here this is 1 and then from here 0. So this is your pi by 2. When the angle changes from pi by 2 to pi here, then you see that the graph is changing its value, like the value of the function is going from 0 to -1. How? Because cos, suppose I take 120, is cos 90 plus 30. So cos 90 plus theta is sine 30, and that is negative, because in second quadrant cos is negative. So this is -1 by 2, that is -0.5. So it is going on the negative side, so it's coming like this, and it will be flipping again from the 0 to -1. So this one goes from here 0 to -1. Then when you go into this is value is pi. So at 0 to pi by 2, the value decreases from 1 to 0, and then from pi by 2 to pi, the value decreases further from 0 to -1, and then from pi to 3 pi by 2, the value increases from here. So this is the third quadrant. So now if I say that the cos, suppose more than 80, like I say 210 is cos 180 plus 30, that is cos 30, and that is negative because cos pi plus theta is cos minus cos 30 minus cos pi plus theta is that cos pi plus theta is minus cos theta, so that is minus root 3. So you get the values increasing like that. Same way you can do all the calculation and you get the graph like this. Now what is domain? So domain, you see that the whole real line is the domain, there is no exceptional. So the domain equal to whole real line, and the range is between 1 to -1. So that is -1 to 1. Now I go for the cosec function. Same way. So when suppose for this section, when 1 to 0, so what you'll get? You'll get your graph from here to here like that, increasing. So when it becomes 0, then you get a line which is parallel to the graph. It's at pi by 2, it is kind of infinite, and graphically it means it is parallel to y-axis. Here also this goes like this. So there you draw a line like this. So it's just like very much like the sine and cosec. At every cusp you draw a cusp upward where the tip is same like this, and wherever the graph is cutting this 0 value, there you draw a line parallel, dotted like that, because there the graph is changing like that. Okay, then here also it will be like this, and the cusp for this will be like that. So this is our, here the graph is not that uniform, so it should be like this, and here you get a cusp which will be acting like this. So for sec x, the domain is, for this sec x, the domain is, you see the domain. So what is domain? Means the value of x-axis, and so but at this point we cannot take this point, we cannot take this point. So 0, pi by 2, this is minus pi by 2, this is minus 3 pi by 2, because the cost is 0 at the odd multiple of pi by 2. So we will write r minus 2n plus 1 pi by 2, where n is the integer. So 2n plus 1 pi by 2 means odd values. So these values should not be included into the domain of sec x. And what will be the range? Range, you see, it is everything but not this part. So you can say r and -1 and 1. Okay, so or you can say that from, like instead of that you can write 1 to infinity, like 1 to infinity union -1 to infinity, because the 1 is coming into the part, because 1 upon sec 0 is 1 upon 1, that is 1. So this point is included, that's why this is close bracket, and infinity cannot be included because it is undefined, that's why it is open bracket. So this is our cos and sec graph. In the next, I'll clean the screen again, and then I will go for the tan and cot plot for the. So I write again here, suppose sine, and then here I write cos. We have angle 0, 30, 45, 60, 90. So sine 0 is 0. This is half, that is 0.5. And this is 0.7. This is 0.8. This is 1. Then here it goes in the reverse order. So 1, 0.8, 0.7. And this is 0.5. And that is 0. And you know that the tan x is sine x upon cos x. At the same time, you know, you have learned this, the sine x equal to 0 when x is n pi, and cos x equal to 0 when x is odd multiple of pi by 2, that is 2n plus 1 pi by 2. Okay, so let me plot my x-axis, y-axis first. So this is my x-axis, y-axis. This is x dash O x. This is y. So first let me locate this pi by 2, then pi, then 3 pi by 2, and then 2 pi. Here it is minus pi by 2, and this is minus pi. So the graph means at pi by 2, at pi by, you see pi by 2, 1 by 0. So this will become undefined. So here your graph is undefined at pi by 2. So your graph will become parallel to, okay, means wherever the cos is 0, that is undefined. So cos is 0 at the odd multiple of pi by 2. So at 3 pi by 2 also I have to draw this, and here also I have to draw something like that. Yes. And then you see that when you find sine 0, what do you see? 0 over 1, that is 0. So that is 0, which the graph will pass from this. And then you sine 30 is 0.5 over 0.8. So it is 5 over 0.8, that is 1 by 5 by 8, this is 0.7. So it means the graph will be black color. So from pi by 2 it will be something like this. So the graph will be coming decreasing, and then it will go like this. Okay. So between pi by 2 to 0. Now if you see from this section, if you go from 0 to pi by 2, then you have 0 by 1, that is 0. This is 0. 0.5 over 0.8, that is 5 by 8. So 5 by 8 is how much? That is 0.7 kind of. So it's increasing. Then here from 0.7 to 0.7, this is becoming 1. So again increasing. And then 8 by 5, so it is going beyond 1, so it is increasing. That's why this graph is increasing from here. But when you come down this is decreasing. Now you draw the similar to this, parallel like this. So it goes like this. That is your tan x graph. Now what is the domain of this tan x? So the domain of, you see the domain means it cannot have this value, it cannot have this value, it cannot have this value. Means it cannot have any those values where this cos x is 0, and the cos x is 0 at x is 2n plus 1 pi by 2. It means your domain is full real line minus 2n plus 1 pi by 2, where n is integer. And then what is the range? Range, you see there is no problem with the range. It goes from minus infinity, it's minus infinity down to the plus infinity up, because this graph is going in this direction, and then it's further in this direction. So what is your range? Full real line. So range is full real line. Now let me clear this, and then I'll draw the graph of chord. Okay, now I thought that without changing this, I'll try to plot the graph for the chord. So the graph for the chord goes like this. I'm using the color change. So it will go like this. They should not intersect because they should be something like that. So it is just like the mirror image of this one, this tan. So this is how the graph of chord is represented. Just the mirror image around this point, and then you'll get the graph like that. And what will be the domain and range of the chord? So the domain range will be as usual, just like the tan. So its range is R, so that range is also R. And the chord is reciprocal of this. So here you will have cos x upon sin x. Means where the sin x is not defined, this means R minus n pi, where n is the integer. This is all. We are more interested because people these days get questions only on the sine, cos and tan. That's why the emphasis should be on the sine, cos and tan. Thank you very much, and this is the graphical representation of the trigonometric functions.